All right, so let me check the clock, and the clock is saying that in 20 seconds it's time to start. I can switch back to the view mode, and I guess we can now start. So, good afternoon, everyone, and welcome to episode 5 of the CodeRefinery workshop. And we have already covered so far in the first part 3 consecutive days all that is related to Git and also GitHub and how to work with Git locally and how to work with other people and collaborate with them through GitHub. In the fourth day, we then had a look at kind of at the core topic of reproducibility, specifically computational reproducibility. And today we kind of build on top of this previous part, but we kind of add some sort of a, how can I call it, like a legal angle, but also ethical angle on how to reuse other people's code, but also how to tell others that how they can reuse our code. How can basically we get cited? So with me today there is Bjorn Lindy. Hi Bjorn.
Hi, Enrico.
And Bjorn is a research software engineer at NTNU. Am I right? Did I
Yeah,
spell it right?
Norwegian University of Technology and Science. Yes.
So do you want to briefly mention how is your normal day at work and what do you do at NTNU?
Yeah, yeah. You see the logo behind me here. It's NRIS. It's Norwegian Research Infrastructure. So that's a lot with data storage and HPC. So last week I had a full support week on the national supercomputing systems. So my job is to yeah, support on HPC systems, but also support research software locally at the university.
Yes. It's nice that in this run of the CodeRefinery workshop, we had many people actually involved with HPC and in general, for those of you who are affiliated with the university, most likely you have access to an HPC cluster, whether it's the university cluster or some national cluster. And this is something that maybe you want to bring at some point into your workflows. But anyway, I'm now showing this, how do you call it, the homepage of the workshop. And today is day 5. So if you click on the link that there says social coding, this will be the materials for today. A quick reminder when it comes to the intro that we have been using this notes document that you should have just received via email. And so if you open this notes document in a browser window, there's a pencil at the very top. So if you click on the pencil, you can basically edit the document and ask questions, so interact with us in the studio. And especially today, the notes document will be very important because the exercises that we will have, they're not going to be writing code, running code, or running some Git commands. The exercises will be kind of discussion-based exercises that will happen on the notes. So please, everyone, open your notes document. And of course, any questions, you can write them here. You can see how I can add. All right, but let's then get actually started with the topic of today. So social coding. Uh, it's nice that the name, I remember the first time I took the CodeRefinery workshop and heard about this social coding, I thought, is this about, I don't know, sitting in the same room and coding together or, you know, but in later I kind of understood that it's more related to the fact that we are not isolated coders, that most likely we work in a system whether we reuse other people's code or whether we create code that our people will reuse, or often we belong to a team, for example, a research group, and it might be that maybe you're the only one who codes there, or maybe there's someone else who's coding there, and you need to share or reproduce what other people have been doing. So in general, in this lesson, we will discuss kind of how and why to share code, but also data, which is important. And when it comes to sharing code and data, you will hear often the concept of licenses that are basically kind of like contracts that are defining the rules on how do we share what we created and how do we reuse what somebody else has created. So again, here it mentions the FAIR principles. This was also, we touched on the FAIR principle last week, last Wednesday, which is this findable, accessible, interoperable, and reusable. Four principles that are basically making sure that the code, but also the data, can be reused and in a way that is legal, ethical, and kind of sustainable, so that other people can build on top of your work. Like most likely in your research work, you're building on top of existing research. So why software's licenses matter? Well, you find, for example, some great code or data that you want to reuse, and you know you kind of want to give credit to to whoever wrote that code or published the data, so that you can actually cite like you would normally cite a publication. But then sometimes you might need to modify the code a little bit to adapt it to your case. It's kind of, we will often talk about remixing bits of code or bits of data, and then it might be a bit less clear how much can you change. Are you allowed to change? Can you do whatever you want? And so for clarifying this, basically we have licenses.
But that's you mentioned that if you're citing a paper, that then there's no license. You can easily build on others people's research or
Mm.
doing your own research. Um, but when it comes to software, you have to be careful because you have to know that you can build on it.
Yeah, that's true. That in a way, I mean, of course, the equivalent is that I might write things in the paper without actually citing, the original source who wrote some statement, and maybe that is not illegal, but it's kind of, in the point of research ethics, it's you can't just copy paste somebody else's paper and plagiarize. But with code, there's another layer, like you just said, there's another layer of difficulty that are immediately from from the first day. Can I just reuse this bit of code that I found online on Stack Overflow, or like we will see later, that some ChatGPT has made for me? So hopefully we will basically clarify this. So maybe very briefly, because before I pass the microphone to Bjorn, in general, maybe today is a little bit more for those of you who are actually coding reusable code so that you can share it and other people can use it. But in general, this will be important knowledge for anyone who has to work with coders, whether in a research environment or maybe later in your life if you go even outside academia. So in general, we will try to cover the basics, but also practical stuff related to all these aspects. So I move to the social coding page and I pass the, so Bjorn, what are the objectives of this first part of the lesson?
Yeah, thank you, Enrico. The objectives of social coding is that we're going to get an overview of motivations and benefits, but also risks of sharing and reusing code. Um, we'll learn to identify whether you can use other people's software. And then we can start out with a discussion, a poll. We'll paste in the 4 questions into the shared document,
Yes,
and you'll
I
get,
just pasted them.
yeah. So you can ponder on this for 10 minutes, and then we'll discuss them in together.
So let's have a exercise where it's this social one. 10 minutes, so we can be back in 19 past.
Hi, everybody. Welcome back again. I hope you had a good time answering the questions. We'll take a look at your answers and your votes. So starting with question 1, why would you want to share your scripts, code, data? And we see many votes for easier to find and reproducibility. That's good. And increased trustworthiness. Others can verify and find bugs. Enable others to build your own popular code. Others can submit improvements and help fixing. We say that there's just one vote on discarding competitors,
Yeah.
and that's interesting. Uh, yeah, I'm impressed by a library like Armadillo, which is a linear algebra C++ library. And I think they kind of take up the space for others, and they use a Apache 2 license. What do you think, Enrico?
Of this first question in general, or?
No, this the response on H, the letter H in the first question.
Oh yeah,
Where,
the discouraging the competitors.
yeah,
Well, I don't know. I it's interesting that there's just one vote
yeah,
for that, but it's true that sometimes competition in academia and science is quite, people cut corners, and if but on the other hand, we are often driven by good ethical principles, so maybe it's nice to see at least that this is also reflected in the audience here, that the majority are, you know, openly sharing for to ensure reproducibility and trustworthiness. But yeah, in me personally, I never thought of discouraging competitors, or I'm actually encouraging competitors to find errors in my scripts. So
yeah, right. Mm.
has it ever happened to you that someone, it's quite rare, but it's not impossible, that someone has found a bug or something in your published code, or
No, not my code. I haven't got that. I haven't published that much code. It's just been more or less snippets to individuals, and
yeah.
then
It,
it's
it also goes to the fact what someone was writing the extra questions at the bottom, that do reviewers, like peer reviewers, actually review also the code of the paper? Because in theory people can find bug in your code, but if nobody's gonna review it, it's you know
yeah. And our instructor from the previous lessons from the East University of Finland, Ian, no, what's she called? Um,
yeah,
she, yeah, she had published a paper on that together with others, where it showed that it was pretty. It was not good when it comes to reproducing results and
mm.
using published software.
Right, so
Okay.
question 2.
Yeah, that's what's the concerning thing for me or for you. And then we see that exposing ugly code is is very um, present.
Yeah,
I have less problems with that now than previously. I do horrible things on GitHub public. So just using it if I have a learning project, I establish it on GitHub, so at least I have it, and then I don't mind having it publicly.
I have the personal motivational factor that from day 0 I start coding as if everything that I'm coding is public.
Yeah.
So then, if even though I might not even push it to any GitHub or something, but already knowing this that someone is watching me, then it's like I name the variables with meaningful names, not just A, B, C, and D, and try to add some comments that which is in general. It at the end of the day, it's not gonna help maybe anyone else. It's more gonna help me in a week or in a month to actually know what I was doing if the code is not that terribly ugly. But question
Yeah.
three and four are more interesting uh, and more, nuanced. Is
Yes.
there anything that you picked from question three, Björn?
Yeah, the first one, I have no idea. Well, um,
What's your opinion on this question? Is software treated differently from papers?
it's definitely treated differently. I mean, papers are the things you get your CVs and credit from, much less so with software. So um, yeah, but we see that there are some answers around that papers are usually one-time publications and software is constantly being improved.
But then, of course, one could also argue that I might, and it has happened to me actually. I've published some software with some paper, but then in the end, never went back to that software. So
Yeah.
in the end, it's whatever version used to be 10 years ago. So nobody in a way should be forced to keep the software maintained and improved, like
Mm.
like with papers, they were not supposed to go back and suggest edits or.
And you have here some code might consider a research infrastructure more than a research output.
Mm.
Yeah, but if code have to be being maintained and will be improved. So these add-ons and changes are often results of research.
Someone did
So
this metaphor
yeah,
that software is like a recorded song. So like basically what a DJ would do, instead the papers are like this, written notes, sheet music. You can't just copy the notes, you must create the original composition but building upon the ideas. Yeah,
yeah.
it's an
Mm.
interesting metaphor. I have
Mm.
to think about it if it works in our context, but it's right. What about question four?
Yeah, when you find a repository with code, would you like to reuse it? What are you looking for? Yes, usually go from a paper to the code and then check whether you understand the code. Yeah, yes, that's possible. I would check for the dates that things are committed. Um, and also see if there are frequent updates to the software. What about you, Enrico?
Yeah, I mean, I agree on what the people wrote here. Especially this, I find it really important that it's maintained. I know that sometimes there's very specific software that maybe that's not been updated in 5 years, but because there's just that, and you specifically need to use that, you know, what can you do? But if I'm choosing between libraries that might do something similar, I rather go for the one that I can see in their GitHub or GitLab repository that a few weeks ago they were doing changes and things like that. So
And
definitely.
the last point here, tests, that's a good one.
Mhm.
Tests shows you how software can be used, so that's very good. But what we now and then experience on the on HPC system is that you download the software, install it, run the tests, and there are 200 tests and 175 of them passes. What do you do then?
Yeah. Yeah,
Is
this is
that
a very important aspect that me, for example, I rarely consider that okay, this library does what I want, just import and use. But it's true, it's very important. All right, so
Okay.
now if we go back to the lesson, so what about these two pictures here, Bjorn?
Yeah, well, we know that we can cite others' papers and from others' research we get new ideas. And so that's if you have a PhD, you don't start out from scratch. You with PhD, if you are a PhD student and are part of a PhD program, you don't start out from scratch. Somebody has written more or less the task for you, and so you have to read a lot of papers and often cite these papers as you progress in your work. Um, doing the same thing with software is, well, we should probably cite software, but you could then have either that your code are part of what others do, or and then you have to relate to others that send you improvements of your code, and others that also want to cite your code. Um, so this is somewhat different than citing a paper which has a much more natural, a common and established way of doing it.
What about like if we consider, because for example, journal policies, I've been at least changing a little bit. For example, when it comes to sharing data, now many journals require a so-called data availability statement. What about the code? Can this be a motivation for sharing the code?
Yeah, I think this can be a motivation for sharing the code, absolutely. Uh, but then, as studies have shown, it's not always possible to reuse the code, though it's shared. It's thing stops despite being shared. But we see here both science and nature has editorial policies for sharing code. And nature has also requirements for sharing the data, and that can be a lot, quite large volume.
Yeah. And so here in the bottom of the page, we have this motivation for open source software, but also this type of scaring aspects. I guess that most people kind of, this was already mentioned by many in question one.
Yes, it was. And also when it came to was scary, fear of being scoped, and also published the
Mm.
ugly code was quite many some thought of.
And the scare that someone might find bugs or
Yes, that
mistake.
was also somebody that signed up on.
On the other hand, one could even consider that actually it's a good thing. I mean, maybe it's not a good thing for the perspective of a researcher that, okay, wow, there was a bug in my code and now all my papers are wrong. I need to retract them all. But then on the other hand, from the point of view of, science and research, it's good that some bug was actually found. So
Yes, yes. It's a double-edged sword.
exactly. Yeah, what about this? And this maybe also comes also with the fact that if I now look also at the research software engineers, that sometimes we need to help researchers to reuse somebody else's code, but the person who maybe invented that code, created that code, they're not supporting it. They're not, sometimes you can't even ask them. So is this also something that maybe people don't want to share their code because they will feel this pressure that forever they will need to.
Support the code and
Mhm.
answer to. frequent questions around the code. Yeah, yes, that can be.
All right. So then basically at the end is code reusability. So what contributes to reusability?
Yeah, we partly discussed it, but uh, that it's licensed, and so you are allowed to use it, and that we will discuss a little bit later on which license to choose. Uh, Installed instructions or tests so you can show how the software is used or the code is used, and that it's not 10 years old but updated with issues and requests and and commits. Yeah.
Yeah. Well, maybe we don't need to do this exercise here because maybe this is a bit more kind of a reflection on this type of issues that we discussed, that you aren't required to support anyone, that it's important to publish the code even though, maybe you will never touch it again. But to wrap up this page, so yeah, what do you want to mention, Bjorn, before we move to the next one?
Yes, here we see whether and what we can share depends on how we obtain the components. But here is your work kind of used in as a software used by others to write articles and promote ideas, and your work is also dependent on others. So so to promote science and create more bang for the buck, it's important that software are citable and licensed for others to use.
And this is what we will cover basically in the rest of these hours together. Right, so if I click next and turn the page, now we finally introduce software licensing. And well, the idea here is to kind of know uh, about the type of basically derivative work, the type of reuse or remix that you can do with others people's software, and of course, how can you share what you've done, and now can you also, get citations from this from the work that you do. And more generally, as I was mentioning earlier, it's important to get familiar with the terminology. It might be that it's not something that you need today. It might be that you will have helpers at your research organization or even in a company when it comes to this type of issues that start to become legal issues. But in general, it's important that you are aware of these things if you work with software. So in when it comes to copyright, so copyright is a type of intellectual property rights, and there are different types of intellectual property rights, more related to kind of trademark or patents or kind of this type of how to protect ideas or
But
better to protect implementation of ideas.
but if you write a piece of software, then it's you as implementer that has the copyright to the code. It's not the university, right?
Well, I've been hanging around too much with lawyers, so they would always say it depends.
It depends.
But at least in all the universities that I've seen, the deal is this, that yes, you have the copyright of the code. I've seen sometimes people writing in the license copyright by name and surname and I don't know, Aalto University. So that it's like I did this work when I was at Aalto University and you share the copyright. But in general, when it comes to, uh, how can I say, to the copyright of an idea, of an algorithm, those are something that they basically you can't really copyright in this legal sense. You can't put a patent. So that in general, copyright and intellectual property rights, they try to protect systems. So the specific implementation of an algorithm, of a software embedded maybe in other parts of a digital system infrastructure, and that you can patent it and copyright it. But if it's that you just invent a new method and it's just a pseudocode algorithms, that's kind of not copyrightable. But then it's the I just added this. Well, here the page starts talking about the concept of derivative work, meaning that sometimes we want to like when we write paper that we might want to reuse what other people did and we might want to cite them. The same is also with software that we don't luckily we don't have to always rewrite all the libraries from scratch and you know any any bits of whatever we need to do with our data can actually be a combination of reusing existing libraries that other people have made public. And of course, the question for us as users of various libraries that are building code is to understand, okay, I built some software that requires kind of installing or calling these other libraries. Am I allowed to do that? Can I then share my code that is built on that? Do I need to, you know, cite the libraries that are being using? Um, we will so changing and distributing software is similar to changing and distributing music. So sometimes you are not allowed to, just reuse or you know take verbatim some piece of code. Some other times you are actually fully allowed, and this is the why these software licenses are basically enabling how much you can reuse and remix in your derivative work and how much you basically can touch. With this exercise, maybe we take it in a minute. I want to add a little parenthesis of something that I added recently to this page, which is something that came up in previous CodeRefinery workshops, because sometimes, at least for researchers, it's more familiar the concept of plagiarism, which is not exactly the same as intellectual property rights. So plagiarism is more related to research ethics, and so you can plagiarize. Let's say that you copy paste the paper, the scientific paper of someone else's, and just pass it as yours. And of course, if your organization or whatever journal you submit that they use something like Turnitin, they will see that your paper is plagiarized because it's basically copy pasted from somebody else's work that you didn't acknowledge. So plagiarism is this type of unacknowledged work. But intellectual property rights infringement is more that you are not authorized to use someone else's work. That I'm not authorized to use, I don't know, some seconds of Bjorn's song to make my own new song unless I ask for a permission. And this is basically the main idea that stands behind these copyright licenses or patents, that it's not just about citing like we would do with the plagiarism from an ethics perspective. It's more saying, okay, I, I, I still cite you, of course. I still say I use your code, but I also follow the rule that come with your code, that come with your patent or whatever intellectual property rights you have. And so this is maybe something that sometimes is not clear, these two aspects, but they're both important because plagiarism from research ethics perspective can in basically end in misconduct. So your papers get actually retracted if you plagiarize somebody without giving acknowledgement. With the software, maybe your paper will not be retracted if you break the license of some other code that you have included in your software. But of course, the people who might have intellectual property right, they could potentially come back to you, and that is like a criminal offense. So eventually, you will need to pay a fine, or if not you, your organization. I don't want to scare anyone with this thing. Actually, I want to motivate people that good thing of open source software and open licenses is to avoid the mess of proprietary intellectual property rights, copyrighted materials. But I'm talking a lot, and it's nice to always see our clever audience. So let me paste this question to the notes document. Now, maybe we don't need to go away from the stream, but we can ask everyone to vote by adding this O or 0, whatever is your favorite, in this example. So which of these are derivative works? I will switch to the notes so to see what people are answering. And these are interesting cases. I would say, let me check. I think I've done them all. So we can see that A is getting lots of traction. Download some code from a website and add it onto it. So
Yeah, A and B, I do a lot.
yeah. Also what we said at the beginning, changing code you got from somewhere. Because maybe like you mentioned, you help some researcher, you give them a snippet.
Yeah.
But then, I mean, for example, this is a clear case that you didn't give a license. You are not claiming any copyright. You will never, sue a researcher from your university. You didn't. But then, do you expect that, for example, your help or your services are, for example, in the acknowledged section of the paper, that they could acknowledge the research software engineer of NTNU, or do you have
Yeah,
this type of?
in some instances the group are acknowledged, not the
Yeah,
individual, but the kind of
yeah.
service that we provide. Yes.
Yeah, but so then this is it. It's still, it kind of goes with this. Legally, they don't need to acknowledge you,
No,
but
no.
ethically, it's good that they
Yeah,
acknowledge
yeah, yeah.
your group. We have the same at Aalto University with the research software engineers and our HPC cluster. So when it comes to E, so completely rewriting code you got from somewhere. Is it derivative work in your opinion, Bjorn?
I'm not sure. I'll think rewriting it can be done in several ways. You have H there, which is clean room design, where you uh, which I think is it AMD that designs the Intel processor or the x86 processor from a clean room design. They just get it described, and I'm not sure. There are some stories, computer stories around clean room design. So
Yeah, it's true. Age is a bit different than E because I could even take a library and all I do is copy it line by line, just changing the name of the variables and the name of the
yeah,
functions.
that's not real rewriting.
you know, but
That's not rewriting.
it's like people, unfortunately, they write essays with ChatGPT, so they copy whatever line of text and then they just add an adjective and
Yeah, yeah.
so making it making it their own.
But there again, yeah, I mean, you like you have in JetBrain or VS Code, you have the GitHub client, which then expands code for you.
Mm,
And what kind of code is that? When is that code it has seen on the internet,
mm.
or does it generate it purely for you? I don't think it does the last one. I think it's get it somewhere.
Yeah, it's a mesh.
Yeah.
It's a puzzle of different pieces.
Yes.
But yeah, this was good, and I would say that you kind of got the got the right answer in the. I go back to the page. In the page, there's a solution that but I still think that sometimes it's always, you know, it's always nuanced and tricky. Um, we mentioned last Wednesday we talked about containers, and containers are interesting because they are like that you can basically look at containers as a recipe of all the system that you need to run your software. So that if I distribute just a recipe, this is how you build my kitchen. I'm not giving you the whole kitchen, just the recipe of how to build it so that you can run whatever food that I'm asking you to make. But one can also basically build the container image and then distribute the binary kind of. And this is again another nuanced thing and tricky thing because in the end, when you aggregate all these things together, I added the reference there from the GPL. If it's just aggregation that you collect some libraries and put them together, but they're still, that someone can basically look at the container image, look inside and see that different libraries have their different licenses, it's okay. But when the moment that you just wrap the container around a run script, that in the end is just whatever name of the command and then some input file that you pass, then you're creating like a new software, like a binary that would have inside all the libraries. And then it gets more tricky because of these licenses that you can already see the picture below, because then it's then you can't just release it with whatever license that you want to release this container image, but you might need to follow whatever more strict license that
Yeah,
is
so if you
embedded.
have GPL copy left
Mm,
inside in your software stack, that then goes for the whole container that you're creating.
exactly. And this is
Mm.
why these licenses that are still open source licenses, but they're called viral because they kind of infect all the rest of the code or software that you are sharing. The idea made basically that, let's say that you build the software so that it within this pipeline or whatever tool that you build is going to call libraries that have different licenses than the very permissive open license that you might want to use. Well, then some licenses of other tools are so strict that they would basically force their license on your license. So to understand this with this picture, which comes from a paper of the European Commission specifically for the European Union public license, one type of open source license. So you can think of the code that exists in the world to be divided between proprietary code that basically follows proprietary licenses, full copyright, and then you have open source code. Now, in the open source code, so this green triangle that you see here, there is like a continuum of different type of licenses that you can attach to the open source code. So some here at the bottom, dark green, they are very permissive licenses. There's basically no condition. Sometimes the only condition is that, well, actually, let's start from the very bottom. At the very bottom, we have this gray block, which is public domain. This basically means that there's absolutely no license, or some type of licenses are called the unlicensed, or this for data they're called Creative Commons Zero. So this is public knowledge, nobody owns it. And if you can release code under this unlicensed,
So
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 that
this is the hello world in C, right? Then that's
exactly,
public domain.
nobody, you don't need to, make sure that you don't offend any developer of C. Hello world in C is public domain. But then you start, of course, having this open source licenses, and the very permissive one, all they ask is that you keep the license if you reuse the code and just what we said earlier, acknowledge that you've been reusing somebody else's code that you're building on top of it. The good thing of this permissive license is that if you have a company, if you work in a company and you need to include some libraries or some pieces of code that are released with this permissive license, then it's possible. So this red arrow means that yes, you can actually include them.
And so, the example I mentioned Armadillo as a linear algebra library, which has Apache 2.0. So then you can include that and use that in your proprietary product that you sell.
Exactly. And I'm pretty sure that many codes that researchers have written are actually now they do exist in actual products that can be in our smartphones or whatever, because they've been released with permissive open source licenses, and then they can be reused basically for commercial proprietary use. But the more we keep on going up in this type of continuum of strictness of the open source licenses, the more we introduce the concept of copyleft. And the idea of copyleft, I don't know how to explain it in an intuitive way, but it would be.
Well, I think the concept is if you go to copyright, Richard Stallman coined this phrase copyleft, and he took it
Mm,
from copyright. And copyright is strong; it's somebody's work, right? And but copyleft then is also strong, but it goes the opposite way. It kind of influences everything it's included in.
exactly. And I guess this is the kind of motivational factor of Stallman and others who promoted these various copyleft licenses, so that you find my product useful, you find my code useful, and you want to include it in your proprietary package, software, whatever. Well, actually, you also need to make your proprietary software basically following the same license.
Yes.
So,
But there is a very interesting link on the weak copyleft to into proprietary licenses, because the difference between weak and strong is worth mentioning,
mm,
and LGPL and also the Mozilla uh, license, which is MPL. There you can have a library that's are licensed under LGPL. Um, so everything you do to the library itself has to be public or open source. But you can use the library in your proprietary software or closed source project. And for
yeah,
Mozilla and for the Mozilla license, that goes for individual files. So you can use the MPL to then go public with individual files, but it can be used in closed source projects without having any consequences for the closed source project.
yeah, this is a great explanation, because then it really makes people understand the importance of this continuum. And I've been reflecting with others in CodeRefinery. We have a nice Zulip chat where we have sometimes this type of conversation. On one hand, I feel that sometimes we should release our software with a strong copyleft, so that if whoever big tech giant will actually reuse our software, they need to also join the strong copyleft. But the problem is that most likely the big tech giant is just going to rewrite my code and not cite me.
Yes,
you
probably.
know, Instead, so in the end, the strong copyleft, although in principle I totally agree, is going to create troubles to actually to my peers, to other scientists who just want to reuse my function or my library or my method. So most of the time you would see research code released under this MIT or Apache or BSD, because then you know that you make the life of other people like you easier, that they can just reuse it, not don't worry too much about licenses and get their papers out basically. So I don't know, do you ever where do you sit in this spectrum beyond
Yeah,
do you
my heart are on the GPL, but my praxis is MIT.
yeah, so basically we agree. And in this picture here, there are also some licenses that are not really related to code, they're more related to data. We will touch on these data aspects. So even though this is CodeRefinery, there will be a data refinery at the end of the day. But we basically have 2 minutes before the break, and we kind of already covered all of this. Maybe we could have a break, 10 minutes break starting now, and then we
There's interesting questions what about Stack Overflow? Not there, but in the if you go licensing situations, because I pasted the Stack Overflow questionnaire into Claude from an Anthropic, isn't it? And Claude answered that the Stack Overflow or the code from Stack Overflow would be licensed under Creative Commons, but not but praxis the praxis for well the practice for small code snippets was that you just could copy and paste it and not refer to where you did get it from.
yeah. But in the end, I think that the terms of service of Stack Overflow is
Yeah,
that it
that
follows
you
this.
that you have to attribute
Yeah,
the where you did get it from. Yeah.
of course. Who does it? I, I sometimes I add it in the comments. This was taken from,
Okay. Yeah.
but
I have seen comments where the link to the Stack Overflow dialogue is so.
all right. But it's 2 p.m. o'clock in Finland, so it's perfect time for a break. Let's save 10 minutes break and get back at 10 past. I will edit the notes document and we can switch to the notes, Jarno. Bye. Hello. Hopefully you had a short break and stretch your legs. There was a nice comment, important comment in the notes document on kind of what are these arrows. So we try to explain a bit, but I agree also with the commenter that maybe this is not the most clear picture for expressing, how licenses interplays. But I think the take-home message is, you know, if for your work, for your daily research work, try to use a permissive license, and maybe when you start working in a larger project that could enforce stronger licenses, remember that then those who want to write proprietary software with your work, they will not be able unless they fully reopen everything. So maybe we will not do this licensing exercise. There are interesting questions and there's the solutions there for you. Just to wrap up this license episode, it's in general, when should I add a license? Where I would say choose a license as early as possible in the project. If you remember what we did on the first week, where we created a GitHub repository using the GitHub interface, when you create the repository through the web interface, it would actually immediately ask you, do you want to add a license? So already that's a good moment that you can already pick a license. Sometimes you don't have all the possible list of all the possible licenses that exist in this world, which brings us to the next topic, that how to choose a license. And it's there are so many licenses out there, and I'm sure every license has a reason to exist, but you can see already in the softwares that you use, if you find the source code of whatever library, that there's a subset of licenses that are more used than others. But maybe what is important for you to remember is that do not rewrite your own license, do not invent the wheel. These specific licenses, the wordings that they include, they are built exactly for those purposes. So it's much easier and better that you find the right license for your case, and then just reuse that license without any modification. There
and
are
and and the reason for you not rewriting or writing your own license is that your license will not be recognized, and then people have to use a lot of effort trying to understand what the implications or your license are.
Exactly. There are different tools out there. I think in the links in the bottom we list more other of this, how to choose a license. This one here, which is part of the Interoperable Europe, is like a European Commission website all related to licenses and software and things like that. And here, for example, you can look at various types of licenses that are available by specifying, what the license can do or must do or cannot do. And you can also, so here, for example, if I write MIT that we mentioned earlier, so we can see that, others can use, reproduce, distribute, modify whatever your work that you release. What they must do is that they must include basically your name and surname and copyright that is there in your version of the license, and you cannot be held liable if they misuse your software. This license is compatible with anything. Basically, it's a very permissive, and so it is a strong community-based license. It's a good license. So this type of tools, again, personally, what I recommend is to check what the people that are making the software, the libraries that you use, what they use, and kind of join their community and use a similar license. It's the it's a kind of a no-brainer. But then maybe if you go work outside academia in a company where maybe code is actually a product of the company, then maybe depending on where you will work, maybe they will specifically use some other type of licenses that might be more strict. So let me go back. Then here in the practical steps for incorporating a license, I already mentioned that what the GitHub interface does, but in practice, one way of doing it is to create a license folder in your project and basically put the modify licenses that you use inside that project. Again, here, if you are not sure how to do it, the best way is to copy what other libraries are doing. But basically, the idea here is that if you reuse in your code, if you embed somebody else's code that was released under their MIT license with their name and surname inside the MIT license, so you can just copy all the licenses from all the codes into this licenses folder. And again, it's a bit like this citation, that it's a small effort for you to include these licenses, but then it keeps a track of the kind of, acknowledging others people work. And maybe right now in universities and academia, it's not a metric that is already used in careers and CV, but maybe, or I feel that it's coming, in a sense that if you share your data, if you share your code, and you do it properly and acknowledge others, this is also going to be an important metric for your academic CV. Something else to mention from this page. Um, so if your work is not derivative work, well, basically we were kind of already mentioned this, that if you don't reuse code of others, and what I mean that you don't include it in your repository, so you can of course still import with the whatever Python or use whatever R library. But if your work is not derivative, in a sense that you're not editing other people's code, then what is important is that you do not invent your own license. So pick a standard license, and the tool that I was just showing is one of them. And then again, you would like to make sure that this is visible in your repository, again with the license folders that we mentioned earlier. so that those who will find your code and want to reuse it, they know how to cite you.
But if you create a GitHub repository and click on the license or select the license, then the license file will be at the root of the repository.
Yeah,
Yeah.
yeah, that's
And
how that's what I do basically
yeah,
normally. Before we switch to the next topic, maybe just small brackets on something that I might ask everyone in who is listening to the stream. Has anyone here not used ChatGPT or Claude or Grok or whatever GitHub Copilot to generate code? So if there's usually always one person who has not used this tool for generating code or generating text. So that person, please write something in the notes document. But most likely you have played, or maybe you're using these tools for work. And these AI systems, they are able to take, they basically are text to code systems. So they take a description of the task as text and they generate code. And of course, they are very useful. But when it comes to licenses, the code that is generated doesn't belong to anyone, or in a way just belongs to you. Means that the responsibility fully lays on you who have generated the code and decide what to do with the code. Will you decide to publish the code that was generated? Well, then you take the full responsibility that you're not publishing actually some verbatim copy paste from a library that is proprietary, or a library that requires one of these very strong copyleft licenses. And unfortunately, how these AI systems out there make, they're not telling you, okay, I generated this code for you. It's actually 95% similar to this existing code from whatever, from this library. So please cite the library. As I wrote here as a metaphor, you can never blame the autopilot or the company who invented the autopilot, but only the driver is the one to blame. So please be careful with the autopilots. Beyond this type of risks of licenses, generated code has been shown to have other types of risks. Well, the most basic one is the risk for your results that you have from the generative work. So you might think that your code is actually doing what you asked, but without code review, you might be that your results are false. There are the risk for the systems in use. Sometimes the generated code actually has malicious code. And I give you here one example. So Bjorn, what does it say here? Are you able to read what is written there?
yeah, I'm reading Microsoft in both instances.
Yeah, so this is it looks like Microsoft, but it's
Yeah.
actually RN Microsoft. So again, of course, maybe if one would zoom in, you would see that this is not Microsoft, it's RN. And often these editors that we use for writing code, they have this monospace fonts, so that in theory, you would be able to see that you're not importing something from Microsoft, but from whatever, typo squatted. But these things are happening, and it's a risk. But if we stick to the topic of these lessons, so to licenses, a recent paper estimates that around 2% of AI-generated code is strikingly similar to existing open source implementation. So 2% is very little. It might well be that nobody in this room and nobody who's watching the stream has ever actually experienced to generate something that is strikingly similar to something existing. But then again, something that maybe you should consider. The way I use this technology is sometimes to, maybe convert a couple of lines into a function or refactor some small bits of code, but I personally find it too risky to, you know, generate 500 lines of code. I don't have time to read 500 lines of code, and I'm not just gonna copy paste them. And even though when I run them, I see that they do what I expect. I don't know if you, Bjorn, what is your whatever moral policy in using this type of tools? Do you find them useful? Do you?
Yeah, I find them very useful. Uh, and also been surprised how good they are
Mm,
to write algorithms. You ask for something and then you get a full algorithm. Well, I haven't been seen algorithms 500 lines long, but 50 lines long, and when you run it, it does things as you are supposed.
yeah.
But I only used it for experimenting. I haven't published any code generated from GitHub Copilot.
Yeah, I totally agree, especially as part of my work, we work with users who maybe have not been trained as coders, and it's amazing that now finally, you know, everyone can code and they can understand, they can read the code. It's also a learning tool because you see a good example of a code, but
Yes.
but at least I'm happy to always remind them of the risks that if they don't understand what a specific line is doing, maybe talk with your local research software engineer or
Mm.
try to uncomment that line, everything fails or what happens. So I don't know where we will go. Maybe one of possible future that I wrote here is that if future version of these tools that generate code, let's say that they would be trained only on MIT code, then
Yeah.
most likely what they synthesize is MIT code, and then we don't have issue. But right now, the issue with these AI systems is that nobody knows what went there, which most likely means that everything went went there.
Yes, absolutely.
So, you know. But yes, so maybe a quick look at the notes if there's any interesting comment. Okay, well, nothing maybe too relevant. We can maybe continue already with the next page. Oh yeah, the bottom of the page, there's many good resources on how to choose a license and so on. So you can happily browse all of them. And I switch to the next page, which is now software citations. So Bjorn.
Yeah, well, there was one question in the comments. Why do we use licensee folder with many licenses? Uh, with them licensees clash each other. One will allow something while other will forbid it. Up to now, I would strictly, I was need thought we need stick to explicitly one license. Yes, I'm not sure what you refer to several licenses, but it could be that if you have imported the licensee folder were used for things that you build on. If you did imported a library from somewhere else, that you had that the license for that library, for instance, that folder. Um,
Exactly.
yeah,
That if I because sometimes you uh, let's take the example of Python. Sometimes you can pip install whatever you need and import it, but sometimes you take a bit of code that was in some appendix of a paper with an MIT license, but you can't pip install it. So then you would need to include that bit of code and this component that you add. You also need to have the MIT license for that component. So if you start building a code, then inside the same repository would have all these other codes, not just import on linking. Then you also need to include these other people's licenses. So I don't know if this clarifies.
okay. Then we'll discuss software citation. We start with some basic questions here. Uh, is putting software on GitHub, GitLab publishing? Or where to publish software? And how can software be cited? Um, how can I make my software citable? So we learned about the FAIR principles in the previous CodeRefinery lecture. So we're not talking about how to get the FAIR principles to apply for software. So is it enough to make the code public for the codes to remain findable and accessible? Well, we don't know what happens to GitHub, though GitHub has been around for a very long time. And GitHub repositories can be deleted, accounts can be deleted. So we have to make a step if we want our software and the software that we depend on to be persistent. We need to use a service like Zenodo and get a digital object identifier to related to the software. Yes, so we can have a short discussion in the chat, or not the chat, but on the shared document.
Yeah, I can copy this too.
Yeah, do you cite your software and how? And if I wanted to cite your code scripts, what would I need to do?
So I pasted these two questions in the notes document. So you can now, those who are watching the stream and have the notes document open, you can add your answers. Yeah, somebody saying Bjorn's voice is not coming. For me, it's fine. It could also be this Twitch TV that you need to set the quality of the Twitch TV stream to source. Otherwise, Twitch will whatever compress video and audio. So if that helps. All right, so do you cite software that you use and how? Let's see what people are writing.
What about you, Enrico? How
Yeah,
could I cite your software?
well, at least in my field, my background is in neuroscience, the usual practice, or I don't know if it's the best practice, but people write papers about the software, or then they want a specific paper to be cited when the software is used. It's not maybe the most, how can I say, research software engineering best way of doing it. I guess the reason is to maximize citations to some papers. So I've seen in neuroscience that there are some papers of these usual tools used for statistics that they have, I don't know, 10,000 citations just because, maybe this most likely people who are citing those papers, they didn't even read the papers, but because whatever you use the tool, you cite that paper. So this is what they do in neuroscience at least.
Yeah.
But if I wanted to cite your code script, what would I need to do? Yeah, also there people are writing citing the paper. I think what I've seen, I don't know if you ever noticed beyond that, sometimes in the README file of the GitHub, they might write something like, if you find this code useful, please cite conference paper or
Yes.
whatever
Yes.
journal article. So yeah, this is kind of course, all checks that people do cite those papers. That's a different story. So uh, so how to make your software citable?
Yes. So here's a checklist for making a release of your software citable. We talked about assigning appropriate license, a description of the software, clear version numbering, author's credit, a persistent identifier, and added a recommended citation to the software documentation, often in the README file. So we have an example of a citations.csv file that can be added to the repository.
Should I check this example? Should I click?
It's further down there, isn't it? Yeah, there you have it. So a message, if you use this software, please cite it as below, and the author, title, version, and date, and the digital object identifier also.
So then this citation CFF, it's like a machine readable citation that then it makes it easier, for example, to track which software is cited. Then I go back to the web page of the course. Yeah. And then how to get a digital object identifier, because you were mentioning that it's
You
important.
did that in, what was it, day 3 of the CodeRefinery course, where you got a DOI from Zenodo, I think. Or was it day 4?
Yeah, in day 4 it's mentioned, but in general, if we have a look at this example here, Zenodo is a tool that is very useful for sharing anything. Can be your slides, can be your code, and the interface is very intuitive. That you can basically create a new object. In this specific case, would be a repository code, and then you can get the DOI and kind of this persistent identifier. Maybe I could ask for those who are writing in the notes that if I know that in different fields they might have other repositories, so if there's something specific of some, or that is something field specific, please let us know. So, oh yeah, this is the same example that I clicked. Oh no, this is another more anonymous example.
Yeah. You see, it's the same thing mentioned here.
Yeah.
Yes. So, and then we mentioned there is papers that focus on scientific software. So if you click the link, we will get to the Software Sustainable Institute. And there's a long list of different journals sorted by topic or fields, I mean, engineering, humanities, and different, where you can publish software.
Yeah, it's nice that this, in a way, compared to the example that I was mentioning from neuroscience, I would rather cite this paper that clearly explains what the software does and what is novel, rather than some, random paper that
Yeah,
that they tell me to 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 cite. But then again, I also see that maybe this is I don't know how recent this practice it is, but I would say that now this type of development work is recognized even in doctoral thesis, so that there are doctoral theses that one paper is just a software actually.
yeah,
And it's good that it's finally like this, that software is not some sort of class B or product of the research world. It's actually as important as other papers, as other type of work.
yeah, yes. Uh, yeah, so there are several sources on how to decide software, and we also see the recommended format that is shared by the different authors. Coming to FAIR for research software, or FAIR for RS. That's how to apply the FAIR principles for research software. Software should have a global, unique, and persistent identifier, DOI. It should be accessible, So it should be retrievable by using open protocols. Interoperable software should use open formats and standards to work with other tools. That's like CSV files or HDF4 and formats like that, NetCDF. And it should be reusable. Software should have a clear licensing, documentation, and provenance. So there's a checklist, fair software, and fair software NL highlights with nice visuals the 5 most important elements of
Yeah,
fair for software.
I really like this. In a way, this fair principle for research software are really, the core summary of these lessons. That if your software, if whatever you're gonna publish along with your paper has these elements, then you know that you're fine and you know that everything is in order. I like this website here, this fair software from the Netherlands. That it's a nice visual website, and you know, if you spend time, it's not gonna take too long. They also guide you, how to choose a license. So they're very good, kind of basic, but fundamental, important information. So let me go back. We basically have covered everything so far. I wonder, should we already have a break now? And then basically this is the last part of our lesson. And then we can finish a little bit earlier. Should we do it like that?
Yeah, you can do it like that.
So let's have another 10 minutes break. We will finish a little bit earlier today so that you have more time to explore all the links that we are throwing to you. And so let's get back to the streaming at 10 to the hour. So whatever, 50. Okay, bye. And welcome back.
Hello,
So
everyone.
now it's the last part. If we have a look at the structure of this episode that we covered today, we talked about the kind of general motivation of social coding. Then we went deeper on the licenses and software licensing. And then we wrapped up with the software citation and kind of a practical checklist for you on how to cite. In this last 20 minutes together, we want just to mention also that sharing data is closely related to software, but the tools that we might use for sharing data, they are a little bit different. Of course, you might have seen that in some Python libraries or even maybe in your own code, if the data is very small, in a way there's nothing wrong to, attach a little CSV into the same GitHub repository. But from a kind of metadata, findability, fair principle point of view, depositing the data in a data-specific repository makes it easier for others to find it. Because if I'm looking for a dataset, most likely I search in a data repository and not on GitHub. So a very useful website is this Re3Data, which is like a list of all possible registry to where they post the data. There are some generic repositories of data that we list here. For example, this Zenodo that we mentioned earlier, but in some specific fields there might be field-specific repository. For example, in the case of neuroscience, there is OpenNeuro in the United States, and so there you might find with this search engine for data repositories, you might find the right one for your case. CodeRefinery, although we have participants from everywhere, but at least we are strongly involved with the Nordics. And there's a list here of some available repositories in Sweden, Norway, Denmark, and Finland. In general, if you are not sure, get in touch with your local support people. Basically, when it comes to the licenses of data, licensing of datasets and databases. They are a little bit different than the licenses that we have considered right now. So there is um, there are basically this type of Creative Commons licenses, which one could consider that they're like the open source software licenses for data. And maybe it's worth spending. Uh, Maybe this is not the best website to show, but in general, the Creative Commons licenses, they also allow this type of how can I call it, viral component. So you might be releasing something that is completely public domain, and that's the CC0. So the data that you publish, anyone can reuse it for any purpose. Or then very common in research is the CC BY, and the BY would basically mean that people have to specify where they got the data, so cite your paper or mention the data set. And more strict, it goes towards the CC BY SA, which stands for share alike, so that if you reuse that data, then you need to also, for your data, you need to also basically release it with the same license. And the most strict one would be that there's no commercial, how can I say, work that can be done with that type of data. In maybe very briefly, in the previous episodes, I mean the previous rounds of these episodes, there have been always questions, often questions when it comes to the licensing of machine learning and AI models. So when it comes to data, AI models are a little bit tricky, that it's not clear if an AI model is considered data or if the AI model is considered software. Maybe it's good to define what we mean is the AI model in the metaphor of the car that I already used earlier. So the AI model is like the engine of the car, and so the AI model on its own, it can go anywhere, it can kill anyone. But once the AI model is put inside an AI system, so it's like that the engine goes inside the whole infrastructure of the car and the software, then it becomes an AI system. And then there can be, you know, it can actually be used. So for those of you who develop AI models and AI systems, there are, or let's say that people are still figuring out what is the best way to release these AI models. And the, I guess, most famous examples of shared AI models are large language models because of what has happened with the AI hype in the past 2 years. And so if you know GitHub, if you've been experiencing with GitHub for sharing code, Hugging Face is like the GitHub of AI models. I will show now one example of this Olmo model. The Olmo model, large language model by the Allen Institute, is one of the few that is truly open in the sense that they disclosed everything, the training data, the training process, checkpoints, and all sorts of that. And so you see, of course, this is Hugging Face. It doesn't really look like GitHub, but there are basically the files and kind of the keep version of the model, because in the end the AI model will be just a gigantic file. And so if I click on files here, you see that these are all the files that are distributed with this AI model. The actual model, so the weights is basically this PyTorch bin or whatever safe tensor, so this very big file, but then there are other metadata files that might be needed.
The training data is there as well, you said?
Yeah, so in their paper, I don't think the training data is now in this specific link that I'm showing right now. This is just for the release of the model, but they also have a repository. I
Okay.
think they have it even in Hugging Face. So in this, under this Allen AI, is the Allen Institute. And actually this model was trained on the Lumi supercomputer. So it's one of the products of the EU AI factories. But anyway, back to the content. So, so these AI models, it's a bit difficult to, if they would be called data or if they would be called software, but at least the AI models that you see in Hugging Face, they're right now released under software licenses. It's also a bit, I would say, kind of funny. I don't know if funny is the right word, but many of these AI models, they are considered open source model, but actually when one really goes and check, there's nothing open source at all. So even the various Facebook, Meta, or whatever big tech that is releasing these open source models, actually everything is quite kept proprietary. But as there is this kind of open washing, so that by attaching the label open source, they can think that they can get away with whatever secret practices, but the lack of transparencies and so on. Compared
Mm,
to, yeah,
Of course, there's no authority forcing these companies to
no,
change their practice.
exactly.
So they can just use the open licenses as much as they want, though
Yeah,
it's not
it's
the
actually
reality.
this paper that I linked here for those who it's also this type of open washy in the AU Artificial Intelligence Act, which I will cover briefly soon. That that is also exactly this, that maybe this regulation that we now have in Europe to regulate AI models and AI systems is using open source even in the text of the regulation in a way that is not what we've been discussing today and in the previous episodes of CodeRefinery workshop. But anyway, um, of course, I would understand that there's maybe a minority of you who will develop AI models and release AI models. But in general, as I just mentioned, for those of you who are doing research, this type of regulations, they don't apply. So for researchers in practice, you don't need to worry about AI regulation, but you might still need to worry about ethics. That if you're building a model that, I don't know, is for operating automatically some drone machine gun, maybe, do you really need to do that? Can you do something else with your clever brain? So this, of course, is you are the judge and your community is the judge of what is good and what is wrong. But in general, researchers have the freedom, even under the EU AI Act, to explore what they want. The kind of open questions that is with the data that is inside these big AI models, it has been shown that you can actually, that these large models, they can memorize some of the training data. And if you, what we were saying earlier, that even with the code that you might generate from some large language models, there is a 2% chance that some of the code that it spits is basically verbatim copy paste of existing code. And of course, this raises concerns about copyright materials or, copyleft licenses when it comes to the code or any other stuff that is inside these models. Right now, there's no decisions. The companies, for example, the large New York Times and whatever these big publishers, they are trying to sue the AI companies for misuse of copyright materials. And but right now, there's no, how can I say, judgment or final verdict. There was recently some big fine to Anthropic, like really in the order of billions, but they are still pending. So because apparently they used some books that they shouldn't even have had access to, to train their AI model. All right, but the ending part, in the way we went quite quickly in this data kind of licensing because it goes a bit beyond CodeRefinery, but it's something that is very important. Many universities, they cover this type of data management and opening data workshops. So I highly recommend you to check what your organizations are are, for example, suggesting when it comes to repositories for data. And here in this final list of references, there's very good tools and very good resources. I'm a huge fan of the Turing Way, which is like an open ebook that covers all these topics. And and in general, I mean, there are also field specific things. So try to basically check for your field if there's something specific. Right. So we're basically done with this episode. We This was a bit of a different episode compared to the other ones in the CodeRefinery because it was more discussion based. I can already ask Jarno, for example, if you could paste to the notes the feedback for today.
Uh, yes, just a moment.
And of course, there might be questions that we didn't answer, we will answer. We will not forget your unanswered questions. We will come back to those. Maybe a bit in the next episode of CodeRefinery. So today was day 5, all about social coding and software licenses. Day 6, next Wednesday, will be about documentation and really how to basically build documentations, and the pages actually that you see with our contents and exercises, they're all built with a similar system. So this will be more practical, day 6, where you will actually have to build a documentation for a software that maybe you made or you will make. Day 7 will be more of an introduction on Jupyter notebooks. And so for those of you who maybe have never used them or are not familiar with all the possible tricks that you can do with Jupyter notebooks, it's definitely an interesting episode. Day 8 and day 9, they go closer to kind of concepts of research software engineering, or in general software engineering, even without research. And day 8 will be automated testing. We kind of touched a bit on this in the week 1 when you were trying to push your changes to somebody else's repository. There was a test running that the ingredients were missing or something like that. So we touched also on this idea of the importance of testing also today. So definitely this is the type of lesson that you want to join to understand how you can introduce this type of automated tests in your code and also
Yeah, and
verify.
it integrates with GitHub, so you get to use the test setup on GitHub, which is very useful.
Exactly, because then the advantage of GitHub is that these tests don't need to happen on your computer, and if someone wants to edit your GitHub or suggest the the testing can already be basically automatically performed. And the last day is maybe this type of more general kind of type of software engineering concepts on how to write good code, and specifically how to write modular code and pure kind of functions. So I hope this was an interesting day, although different, a bit different than the others. You can still ask us questions in the notes document, but as usual, we have this feedback section. So if you edit the notes and scroll to the very bottom, you can add some comments. So as you can see, we try to change the lessons so that every different run of the workshop, we include new materials based on your feedback. So if you think that something was missing and something should be expanded, or that there was some too much of something, please comment so that we can improve for the next run. All right. I don't think we have anything else. We end up some 20 minutes earlier today. Thank you, Bjorn, for being with us
Yeah, thank
today.
you, Enrico. And thank you, Jarno.
Yes, thank you, Jarno, for the broadcasting studio. And
And thanks to the audience, to the participants.
exactly.
Thanks for showing up.
Thank you also for the feedback that I can already see here appearing. And so keep on writing, and if there's other questions, write them there, and we can answer. All right, see you in 7 days then. Bye bye.